We also don't know
Hello.
when it's gonna be
Can you hear me
back.
okay? Everyone's mics work?
Hello?
So Mickey, Ryan, Chad. So I was thinking about the idea of a panel, and I do a lot of podcasts. Some people have heard my podcasts, and I thought it's interesting. We don't get a chance to hang out a lot, right? But it's not often we get to hang out with you either. And so I want this to be actually more of a town hall discussion, maybe on the state of data engineering or whatever topic. So they have no idea the questions I'm going to ask them. I don't know the questions I'm going to ask them either.
They refuse to tell us.
They refuse to tell them. Hard mode. But we'll get started. And like I said, I want this to be very participatory with the audience as well. So feel free to ask us questions. We might ask you questions. So again, let's get to it. So we're at a data engineering conference in Australia. I guess, what do you think are some of the key things a data engineer needs to be successful in 2023 and 2024?
Well, I can maybe kick it off with some of my opinions. I think one of the biggest changes that I've seen is that for the past 4 or 5 years, the scope of the data engineer was limited to building pipeline. That was the gap that the data engineering team was filling. But more and more, I think that companies are realizing that there are other big holes in data management that need to be filled by someone, and many different team compositions are not, they're not utilizing the data engineer to their full effect, in my opinion. So as an example, I think data modeling, Joe, you talk about this all the time, I think is hugely important. But if you only define a data engineer as someone who is constructing the pipeline, then it's kind of questionable whether or not modeling falls under their scope. Same thing with understanding the contents of the data or its quality. All of these things, I think, there's a lot more of an inclusive scope when it comes to data management than just pipeline development. And data engineers starting to think beyond that, I think, is essential in 2023.
Yeah, and I think more with less in general is a common theme here. Especially with economic question marks and no longer in the zero interest rate phenomenon world. So I think more with less. So they need to expand their scope beyond the data pipelines into looking at really the data team's there to provide value to the organization. And if they're not providing value, then they could become victim of the next layoff or what have you. So I think trying to figure out where is that business value out of the data. And, luckily, I think at the same time as all these economic conditions are big question marks, the whole world of LLMs and AI bringing to the forefront has also happened. So from a data engineering standpoint, people are looking to the data teams for better data quality to give them better answers so they can use some of these, the new AI technologies and such. So, I think combine this all together is the job is tougher, but probably more interesting in the next couple of years.
I think I can kind of speak on from the ML perspective as someone who's had both really great and sometimes not so amazing data engineering partners. So I think there are 2 or 3 areas of opportunity for data engineers now in terms of growing their careers, but also to a certain degree job security, I guess. So the first thing that I kind of see missing as the ML partner to a data engineering team is that a lot of data engineers are their mindset really is more around analytic engineering as opposed to actual data engineering for ML use cases. And I've seen this a couple times where a data engineer would say oh, this is totally modeled and this is clean and all sorts of stuff. It's yeah, great, but except we can't actually use this for machine learning. And we have to sort of do a couple things. So for example, target leakage or data leakage is a big deal in a machine learning model because ultimately the goal of a model is given some amount of information, you need to create a prediction or inference without other information, right? So for example, if you're Uber and you want to predict how much the price for the fare is, you have to do that based off of whatever information you're given or whatever, like the estimated like miles or you name it. But when you're training a model, right, you can have leakage where somehow there was some leakage of like the fair price in the data set. And so that's like one really big area. A second area that's like really important also is like distribution shifts for like machine learning models. At the end of the day, they are like statistical, mathematical mappings. And so they can be really, really sensitive. So you can't actually take a model and just kind of throw it at data and kind of call it a day. So that's like a huge difference. I mean, I know, right? Like you should be able to do that, but you can't really actually. So that's like one thing that I feel like is kind of missing as like an ML partner to data engineers. And I think the other thing that like I think about a lot is a lot of times like there is kind of this weird sort of headbutting between data engineers and ML engineers in terms of responsibility over like featureization and all that other stuff. And like at the end of the day, I do think like ML engineers, like they do need to have a certain level of software engineering skills, right? Like the data engineers cannot always be like picking up for them and like rewriting featureization pipelines and all that. But at the same time, like I think oftentimes, right, there's data engineers, there's the ML people, and then there's like the front end folks. So for example, you might have leadership saying like, hey, we need to measure how well a model is doing, or we want to start enriching our existing like data set or like data warehouse or whatever, so we can do new like innovative use cases. Those conversations should be a collaboration partnership between data and ML people. And a lot of times it seems like they're not. Right. And that's not always the data engineers like responsibility. That accountability lies on the ML side of the house too.
That's interesting. What are you seeing out there? I'm curious about the audience. I'm going to reverse the panel and ask if anyone wants to take a crack at this. Like, what do you think it takes to be successful in data engineering these days?
Anyone?
Get him a microphone. So, thank you.
Was that hunger? Was it? Really, to me, it's about attitude more than anything. You can get people that are smart, people that are bright, but you can have a bright person, you can't lead them toward it. They need that hunger. It's almost a thirst for learning because it's going to keep changing and you just need to be able to adapt to whatever's coming along. And
learning.
The desire to get the end product out.
Yeah, it definitely resonates. I think it was interesting. I remember somebody asked Warren Buffett once at one of the shareholder meetings, what is how he would invest in a hyperinflationary environment. Who knows what hyperinflation is or has heard of it? Anyway, it's like when things get really expensive really fast. And he said it's probably the wrong question to ask, right? If you can invest in yourself and invest in your learning every day and become like the best version of that, like that's the best investment you could make. And I thought that was really good investment advice because it's something people can control, you know. But I totally agree. Like continuous learning, it's one of the traits I look for in a candidate is just people I like to spend time with. It makes more interesting conversations, I think, versus the type of person who's really stubborn and doesn't learn anything and is dumb as a brick. But they're also everywhere. Does the audience have any questions for us?
Just an observation and a question and observation. So like, I think especially sometimes you talk about like the ML engineers, they're not talking to the data engineers, and data engineers are not talking to the software engineers. I guess like, is that most of my like career, I haven't had that problem because we just kind of did everything all together. And so is this kind of maybe like, is that a problem because the companies are much larger, or is this like, I guess one solution would be, okay, everyone kind of rotate and kind of just learn everything. Maybe that seems unreasonable in my mind, but I guess I just want to know like your thoughts around that. Maybe it's because if you have such a large company, I can understand you have to break everything up. But if you have smaller companies, like you can kind of get that flexibility. So I just interested about your thoughts about that.
Maybe should we actually throw that out to the audience of like how many people in the audience think that there's communication challenges between the different engineering groups involved in your data work? Okay.
Yeah. So I think that we can actually, I think that there's a lot that data teams can learn from software teams, because I think over the last 20 years, the engineering organization has been through similar challenges. And I think that in data, there's a few problems that manifest in terms of gaps that emerge between the different job functions within a company. So if you look at the evolution of a code base over time, for example, nowadays we're using tools like GitHub and GitLab and things like that. And so when an engineer is making a change, especially in a very microservice-y, semi-isolated environment, then they are usually tagging the engineers that need to care about those changes on the PRs. So within one team, you usually see a lot of really great communication about how code is evolving over time. And once you get sort of general adoption of these communication mechanisms across the company, then it becomes way easier for a security engineer to have a conversation through the medium of GitHub and pull requests with a front-end engineer or with a back-end engineer. So there are mechanisms of understanding changes, and there's also an incentive structure that's put into place for every engineer to stay on top of those changes and provide good feedback. I think the problem in data is that generally we care a lot less about changes that are happening within teams and more so about changes happening across teams. So you might have a software engineer that's working on a pricing system, and that data is ultimately being used by a marketing team that's multiple different transformations downstream. And both of these two sides are using the data in a totally different way. So it can be very, very hard for each side to understand, why is the data changing? Why is this data even important in the first place? What is it going to be? How do I put how do we keep people in the loop? So I think that this communication problem really comes down to Conway's Law, and the organizations reflect that, right? When these two sides are not able to communicate effectively.
Wait, for the audience, who knows what Conway's Law is? Would anyone like to describe it really quick, or Chad, you can?
Yeah, so Conway's Law basically states that your organizational model is going to be a reflection of the communication mechanisms within a company. So if you've got engineers that are able to talk to each other, then you'll see your organization structured in such a way that facilitates that communication. And in data, I think that that's a really big missing piece right now.
Any other thoughts on this?
I kind of want to add on to, it's funny because I remember in 2013, 2014, my second job was working Salesforce administrator, right? And I remember I had started doing a little bit of consulting, and I remember thinking my God, who gave all these people the power of a relational data warehouse with all these rules and all this, all these different kind of features without giving them the actual best practices for how to actually build and maintain it, right? Because realistically, how many of you have ever seen a Salesforce instance, a clean one in your life at this point? Probably very few. By the time you get there, it just looks like absolute trash, and they're just supporting everything with fields and workflows and all that, right? And that's something that to me is sort of interesting on the ML ops front, because over at MailChimp, over at Intuit, even at the various companies I worked at where we were building ML platforms, we were always somehow confused as to how to measure the success of an ML platform. And it's kind of weird because if you think about it, product managers, growth managers, and all that have actually sort of figured that out for consumer applications and mobile apps. So it's this weird kind of cycle where we seem to we either don't remember or don't know what other people have done, or we feel our situation is just way too complicated. We can't adopt the same practices. And to me, that's always been a little bit if we were willing to look outside our niche areas or our specialized areas, we would see that a lot of times the tools have been developed, not necessarily the technical tools, but the procedural tools, the operational tools, right? The concepts, the ideas. We could be pulling it in. We could be doing things, for example, actually measuring the efficacy of our platforms, whether it's data or ML, we could be doing things, for example, like understanding adoption versus like engagement, understanding what the right level of attraction for our platforms are. And yet we just, a lot of times, just, I don't know, like we just kind of throw up in our hands. It's like, oh, data and ML, it's intrinsically hard. It's, probabilistic. Like there's no way to measure it. It's like, that's not true necessarily.
It's ironic, obviously, for the data people to say it's intrinsically hard and impossible to measure.
Yeah. What have you seen? You've worked at some pretty top name companies. I mean, that I would think had the communication down to a T. I say that kind of.
I don't know. It's like I've worked. For those of you who don't know my background, I spent a couple years at Databricks before MotherDuck, like 4 or 5 years at Neo4j before that, and then about 8 years at Google before that. And I think that these were all very highly growing organizations, and from that perspective, things were a mess, right? Like as you were putting it with the Salesforce instances, I actually think of like, a messy Salesforce instance is just an opportunity for a new CMO to come in and spend their first year fixing the Salesforce instance and then moving on to a new job.
Attribution rules.
The Salesforce and Marketo and such. But the attribution models especially. But no, I mean, I think that things, I think Chad's point in terms of applying software engineering principles to data makes a lot of sense. And some of the organizations I was at like definitely tried to use those software engineering principles in other parts of the organization to pretty good effect. I think overall that's just learning from other disciplines. I mean, you and I were chatting, Joe, about like I worked for an architectural software startup briefly. And like, there's all sorts of great books on design patterns in architecture, which are basically the same thing, map over to software. We just need to take them another step, map them from software into data, and also look at the communication patterns in that way too. But I think it Google, for instance, very special environment because every product manager and all, and this was 15 years ago, could go in and write their SQL to query their data, and this was an expected thing, and they would file bugs if the data was wrong, and like so. It was a little bit different environment than what we have on a day-to-day basis nowadays.
I think there's actually something that you said, Ryan, that's maybe worth clicking into a little bit more. I think something that we oftentimes don't talk about as an industry, especially in this sort of modern cloud ecosystem, is how the use cases for data evolve and what that does to an infrastructure over time. So, back in the 80s and 90s, when you were standing up your data ecosystem, it was a lot of work, right? Like you had a data architect and you would have to think about sort of like all the various normal forms, and then you'd have to figure out, okay, what is our ETL system going to be? And there was one person sort of thinking about all the transformations, and then you'd construct your data warehouse, and like it was a lot.
And 5 years later, you would cancel the project because you haven't yet built your data warehouse.
Yeah, exactly. It was very, very slow, well designed, but unbelievably slow, and oftentimes somewhat disconnected from the business value. And I think now we've kind of completely reversed course in the opposite direction, right? Now what we've said is, hey, we don't really need any standards at all. We're going to move to microservices. We're going to dump all of our data into a lake. We're going to have the data engineers create the pipelines, and people can basically just start using it however they want. We have very few standards. So I think like that's one thing that's changed. And then I think the other thing that's changed is these days, if you are using data as an early stage company, and I've talked to a lot of earlier stage companies that are beginning to use data, and usually it's okay if the data is directional for their first set of use cases because it's typically analytics oriented, right? It's like, hey, we're still trying to find product market fit, and I want to know how many people are using our website today, and how many purchases have we had today, and what is our churn rate? And if these numbers are off by 10 or 15%, it's not the end of the world, right? Like no one dies, no one necessarily gets fired. but 7 or 8 or 9 years into a company's existence, and now you're thinking about an IPO, and now you're thinking about AI and ML, and you've got all of these accounting liabilities and compliance and things like that. Now the requirements of the data have gone up substantially, but the infrastructure itself has not necessarily kept pace. So you've got people that want to use data and they want the accuracy, but what someone built at the beginning of their journey was designed for directionality, not accuracy. And now people are trying to deal with that issue retroactively.
I mean, we talk a lot about like incentive alignment, right? And I think like one of those skills that's missing for data engineers today, and also like ML engineers, is how to gracefully like update your like legacy stack. Like how do you do like graceful adaptations? How do you, sort of build for what you need now, but also build for like,
But I guess it begs the question: do you need to update your legacy system? I think Corey Quinn had a good thing to say about legacy, where he said legacy is a condescending term for things that make money.
Yeah. Well, so what MailChimp did that I thought was really, really smart was so MailChimp's a 20-year-old company. They were private, which means that they could make a lot of engineering decisions on a much longer time scale. They didn't have to necessarily show insane growth because Ben and Dan were the only real key stakeholders in that company that they walked away with $12 billion, $6 billion each. Anyway, we're going to move past that real quick. But so they could afford to make those decisions on a much longer time scale. And so, for example, let's see, it's a 20-year-old company. It was only maybe 3 years ago that they actually started, 3 or 4 years ago, that they started the movement to cloud. They have like 2 to 3 like on-prem data centers still. Moving the shard was like a big initiative. But what they said was like, hey, look, like this hosts, one of the largest like email transactional databases and, applications domestically in the US. We're just not going to touch that stack because if we screw that up, then that's really, really bad for all of our customers who happen to be small, medium-sized businesses. But they did want to utilize, first off, create some more sort of data infrastructure because they want to do more sophisticated ML. Their very first model ever was written in R, and it was a really janky spam detection model that essentially none of the data scientists wanted to touch. So they kind of just kept it running and had all these like if-else statements and just random stuff, right? But that was the decision they made, was they're like, look, we know we want to take advantage of these new use cases. So what we're going to do is we're going to, get set up with GCP. We're going to split out the data engineers and like the data scientists into like a different sort of stack. And then that was part of the role of one of the teams, was they managed the Airflow jobs to like copy data back and forth and to clean and all the other stuff. And so they made that decision where they're like, we're going to approach it from first moving a shard to see how that process is. But we're also going to still, try to take advantage of the use case without kind of killing the legacy. And I thought that was a very pragmatic, great decision that they made. I don't necessarily see a lot of companies making that same decision for various reasons.
Use case oriented.
Yeah, use case oriented.
Right. Well, I think, Joe, to your point, I have seen so many companies that are in the process of doing their cloud migrations, and it's more driven based on fear of missing out, right? FOMO. Everybody else is moving to the cloud, so we've got to do it too, rather than if we move to the cloud, here are all the things that we get, here's how long it's going to take, and here's all the value that they'll make, the ROI on that transition.
Yeah, and I think there's definitely heroics too. I mean, I think you brought up the example of a CMO who wants to come and change the sales force and the attribution model, because I mean, you aren't paid to come into a new job and appreciate what was there before, right? It's like, the moment you get hired, it's like, oh, that idiot that whose job I took. I mean, everything they did was trash, including them. So
I think the other part though is hiring is like, you kind of need to use what is modern and hip and cool in your organization to bring good talent into your organization. So there's these weird interplays between, the hiring won't let you keep a legacy stack. And if you keep a legacy stack, then you end up I worked at a university and we had like a team of 4 people that were there for 40 years plus at the university, working on this mainframe system that was the legacy stack that stuck around and maintained. But like, you weren't going to hire new people for that, right? Like,
I remember one client I had. It was interesting. They're running on a 1980s era DB2 mainframe, and the guy who originally programmed it, we'll call him Bob. He didn't document his code. Nobody knew how it worked. Bob would show up to stand-ups every day, right? Bob was getting kind of old at this point. And a few days go by and Bob doesn't show up for stand-ups. About a weekend, you realize Bob's not alive anymore. Yeah. And this whole thing was in his head. I don't know why he didn't document it. Nobody asked him to document it, so he just clocks in, taps on his key. Has anyone seen an IBM DB2 database, by the way? Like the columns are like 7 characters, like inscrutable. You cannot figure out what's in here. That's what happens. So anyway, fast forward, that order system that's being managed, it went down a few months later. And for every hour that was down, the company, it took them 24 hours to get back. So it was down for a few days, and you can imagine the cost of that. And this is a many billion-dollar company. So
this is why like some Spark influencer that I know was like, when I get old, I'm going to be sitting in my retirement home writing Spark jobs for folks. Like I'll be 80-some years old writing and fixing Spark jobs, and I have my career for life.
Oh yeah, I know who you're talking about. Yeah, the person's going to have a fruitful career in the retirement home, eating prunes and fixing Spark jobs. So
One would be so blessed to have that kind of lifelong devotion to something. I know I'm not capable of that. I also haven't had kids yet, so maybe I will someday.
Well, I mean, Spark could be your kid, or something like it. So
could be.
Never know.
I mean, I think that is like kind of the thing that I do sort of wonder a little bit about sometimes is people being so stuck on technology tools and choices. When it's like technology changes all the time. It was interesting because, like, for example, Pragmatic Engineer, right? I think he wrote about this in a blog post where you change teams or jobs as an engineer. You learn a new language. Did you exceed expectations with that? You go to a new team, you pick up a new framework, and then you do the thing. And he's like, no, you do not exceed expectation. That is literally you meet expectation. Yeah. Because that's your job as an engineer, is you go learn what you need to and you go do the job. And so this obsession sometimes with like specific tools to me is a little bit odd, but.
Got a question?
Yes, I have a question. And thank you for all speakers. Really good presentations again.
Thank you.
I think, I don't know everyone here. I think many of data engineers, we work for big organization because the big organization has the privilege to own lots of data. So this is why our job all stick in those organizations. But in last 10 years, the data field has been dramatically changed. And so many tools, so many new things. What do you guys advise about our career? Like, say, for example, I'm working in a traditional industrial. I think so far I'm good, but what's your advice for everyone else here? Do you see any other chance for us, such as I know we talk about ChatGPT, we talk about AI tools. Are we able to use AI as an assistant or use other source to help us to pursue or explore a new way, a new path, or even a new career without the big organization, such as like a startup, or I don't know, I just thought the whole industry changes so much. Where's our future position? Except for learning. Learning definitely good, but any advice? Thank you.
I think we have 1 minute per answer too. So Chad, 1 minute, how would you solve this?
Yeah, so I think my recommendation, it kind of goes back to the what we were chatting about at the beginning of the panel. I do think that data engineers will have a greater job security and more job satisfaction if they begin to move beyond pipeline development as their core responsibility. I think that if you're talking about the application of AI and LLMs and these types of things, I believe that we're all kind of marching in the same direction. I think that we're definitely heading to a world of LLMs at some point. I think the problem is that we still have a lot of foundational data issues to solve before those LLMs actually become a meaningful improvement in our work life. So I think focusing on the data engineering team focusing on the human problem is probably the biggest bang for your buck. If you can help teams communicate better, right? One of the kind of what we're talking about, like if data engineers can serve as those facilitators, I think the job security is there, and I think that frees up the data engineering teams to focus less on as they're being middleware less, and you can actually implement things like LLMs and Gen AI.
Ryan?
Yeah, I don't think I have anything to add on this one.
Oh, okay. Well, Nikki, you have a minute and a half to give an answer.
Well, number one, I love Copilot. I love ChatGPT. My partner is a designer, and he also really likes Midjourney and Stable Diffusion. Why? And it's because we can outsource all the garbage work that we never liked doing in the first place. We convinced ourselves we liked doing it because we were like, to a certain degree, like as a craftsperson, you should understand all the tools at your tips, and you do tend to kind of fall in love sometimes with parts of the process. But at the end of the day, like your goal should be to, I hate saying deliver value because it's just, you hear it everywhere, but like, it should be executing on certain things. It should be delivering, it should be shipping. And the reality is that whatever principles you can have about it, you can bet that someone who is hungry is going to use whatever tools are out at their disposal. Now, that being said, right, 2 challenges with LLMs. 1, hallucination, really huge challenge. Even using like RAG or retrieval methods won't necessarily solve that. So you need to have a human, guest checker there, and you are the human guest checker. So really, you are just orchestrating the tools at your disposal to kind of execute on a design. And then the other kind of second challenging bit behind LLMs is, like, once again, they don't solve a lot of the, like, if you look at the concerns about vanilla ML and concerns about implementing LLMs for organizations, they're like literally the same concerns in the same proportions. So that, I think, says something about how tools have not solved those problems.
Good question. Thank you, everybody.